10 out of 5, so no starter today, we're just going to jump straight in. So we are going to start our third and final unit, which is unit 3, and the first topic we're going to do from that is metals. Okay, now the good thing about metals is in third year last year you would have done a lot of this already, okay, if not at all. So we're going to start just with a recap. Obviously if we're talking about metals we need to look at the bonding found within metals, and hopefully you remember from unit 1 that the bonding is called metallic bonding. Okay, now we'll talk about a wee bit about what metallic bonding is, etc., and then we'll start going into depth. Okay, so metallic bonding, you should know this from unit 1, is the electrostatic force. Okay, so it's the electrostatic force of attraction between positively charged ions and delocalized electrons. Okay, so between positively charged, we'll expand that a wee bit, metal ions, okay, positively charged metal ions and delocalized electrons. Now you should know delocalized just means that they're free to move. Okay, now obviously you should know this as well, but we're just going to draw it again. This is the structure of metallic bonding. Okay, so it's in a lattice structure, and remember a lattice is a repeating pattern going off in sort of every direction, so it repeats all the way to the right and it repeats going up and down as well. Okay, so if I just sort of highlight that there is your positive metal ion. Okay, and obviously it becomes positive because it's lost an electron, it's donated the electron into this wee sort of C. Now in between the metal ions you have the delocalized electrons, and you should remember that the delocalized electrons, that makes up the C of electrons. Okay, so that's a delocalized electron. And the metallic bond is the electrostatic force of attraction between positively charged metal ions and delocalized electrons. So see this here where you've got a delocalized electron and you've got that attraction between the positive centre. Okay, so that attraction between the positive metal ion and the negative delocalized electron, that there is your metallic bond. Okay, and you have, obviously you've got loads of metallic bonds found within metals. Okay, now this next part, a lot of people always sort of forget, or they mistake it. Metallic bonding involves only one type of metal. Okay, only one type of metal. Okay, so you can't get metallic bonding between sodium and lithium, you can't get metallic bonding between copper and calcium, you can only get metallic bonding within copper, within zinc, within sodium, etc. Okay, so example, sodium metal contains only sodium metal ions. Okay, now you can't bond two metals together, but you can mix two metals together. Okay, and a mixture, again you should know this, but a mixture of metals is called an alloy. Okay, you should know that from unit 1. Again, this is all recapping. It's all recapping. Okay, now need to obviously talk about the properties of metals a wee bit. So metallic bonding involves strong electrostatic attractions. Electrostatic attractions, therefore lots of energy is required to break them. Okay, lots of energy is required to break the bonds. So if we've got lots of energy needing to break the bonds, that means that metals have high melting and boiling points. Okay. And the next property you need to know about metals is that metal elements are conductors. Okay, and again, this is something you've known since probably first year. They are conductors of electricity. Okay, but why are they conductors of electricity? It's all to do with those delocalized electrons in that sea of electrons. Okay, so the metal elements, are conductors of electricity because the delocalized electrons make up a sea of electrons which allows electricity to pass through. Okay? And that's it. Okay, so we've spoke about metallic bonding, but again, we've covered all of that in Unit 1, so this shouldn't be brand new information to you. Right. So the next one we're going to start looking at metals in a lot more detail, and the first thing we're going to look at is reactions of metals. Now again, you would have done this in third year, so hopefully it's not too sort of taxing for you, but we'll go through it. Okay, so first things first, there are 3 reactions you're going to learn. Okay, there are 3 reactions, in fact not that you're going to learn, that you need to learn. Okay, so there are 3 reactions you need to know. Okay, you need to know what the reactants are, and more importantly you need to know what the products are. Okay, so the first one is going to be when we react a metal with oxygen. Okay, I want you to have a wee think from third year, if you can think what product we get when we mix a metal and oxygen. Yeah, we react a metal with oxygen. The next reaction is going to be a metal and we're going to react it with water. Again, we have 2 products. I want you to have a wee think. And the last one people tend to forget, is what happens when we react a metal and an acid. Okay, what 2 products do we get? Now what we can do, okay, now unfortunately we can't do this because we're not in school, but by observing the rates different metals react at, they can be arranged in order of reactivity. Okay, in order of reactivity. Hopefully this is all coming back to you. This is known as the reactivity series. Okay, the reactivity series. So what we'll do, we'll look at each one in detail. So the first one we're going to look at is a metal plus oxygen. Okay? Now, we will look at the product. Hopefully you remember it, but if you don't worry. So, the experiment you would have done in class, if I just very quickly draw this up. Okay, so line there, line there. So I'm going to draw a test tube like that. Okay, now it'll be quite hard to work out. Okay, so what we have here is we have, if I just label this, we've got mineral wool, okay, ceramic wool, so that's mineral wool, and in the middle of those two pieces of mineral wool we have the metal, yeah, whatever metal it is we are reacting with oxygen. Now what we want to do is at the bottom of the test tube, this here, we would put in some potassium permanganate. Okay, it's a nice sort of purple colour. Okay, potassium permanganate. Now what that does, the reason that we've got that in that test tube is that potassium permanganate, sorry, releases oxygen when heated. Okay, now obviously we are reacting a metal with oxygen, so by heating potassium permanganate, it releases oxygen, and the oxygen will pass over the metal, and we are obviously heating up the metal as well so that it becomes a lot more reactive. Okay, now when we do that, when we react our metal with oxygen, what we get is we get the product metal oxide. Okay, so that's our first reaction that you, quite frankly, you need to know off the top of your head. Metal plus oxygen gives us a metal oxide. Now, that's not quite difficult to remember, so hopefully you're okay with that. Now, basically, whatever metal we react, we just sub it in. So if we reacted sodium, sodium plus oxygen gives us sodium oxide. Lithium plus oxygen, lithium oxide. Okay, so let's write that. So sodium plus oxygen would give us sodium oxide. Yeah, nice and easy. Lithium plus oxygen would give us lithium oxide. Yeah, and so on. Yeah, magnesium plus oxygen, magnesium oxide. Calcium plus oxygen, calcium oxide. Yeah, you get the picture. You get the picture. Now the second one, the second reaction we're going to look at is metal plus water. Okay, again, we're going to get two products. So I want you to have a wee think. Can you remember what the two products were? I'll give you a clue with one of them in a wee while. In fact, one of them burns with a pop. Hopefully that helps. So, when we react in metals plus water, it's important to know that only very reactive metals react with water. Okay? So, that would be like your alkali metals. And you would have all seen the experiment where you put the alkali metals in water, and as we go down the group, they get more reactive. Okay, so lithium is the least reactive, followed by sodium, and then potassium starts to burn with that purple flame. It starts to move about very quickly. Okay, so very reactive metals like your sodium, lithium, even calcium, etc. Okay. Now, if we were to put magnesium or zinc, yeah, they're very slow. Okay, magnesium and zinc are slow reactions, and iron plus water is very slow. Okay, and that's your whole rusting. Yeah, well, iron rust, it's a very slow process. Yeah, you can't see it happening. Yeah, it takes time. It takes time. And what you do need to know, quite important, is copper does not react with water. Okay, and that kind of makes sense, and that explains why we use copper in our piping for like sinks, baths, etc. We would use copper piping, and that's because the copper doesn't react with the water. Yeah, now you wouldn't want to make your pipes out of, say, sodium, because, well, the water would react and you've got a reaction going on. You don't want that. Okay, so copper does not react with water. And I did say this earlier, the gas released with a metal plus water burns with a pop. Okay, and hopefully you know that the gas that burns with a pop is hydrogen. Okay, so our products, a metal plus water, we're going to get a metal instead of an oxide this time, because we're adding water. Yeah, hydro is another word for water. We're going to get a metal hydroxide. Okay, a metal hydroxide, and the gas that burns with a pop, we're going to get hydrogen. Okay, so that's our second equation, second reaction involving metals, and one that you need to know this. Okay, basic stuff, you need to know it. Yeah, metal plus water gives you a metal hydroxide plus hydrogen. Yeah, now the last reaction, and often one that people forget about, is the metal plus acid. Okay, and again we get two products. Now one of them burns with a pop, so one of them is hydrogen. Yeah, I'd be very impressed if you remember from third year what this product we got here, but I'll give you a clue. It's one of the products we get in a neutralization reaction. Yeah, remember neutralization, acid and a base, we get two products. Unless it's obviously a metal carbonate, we would get carbon dioxide. Right, so the thing you need to know about the thing you need to know about metals and acids is that only certain metals can react, obviously. Yeah, very much like oxygen, very much like water, only certain metals can react. So metals higher than copper, and I'm going to use the electrochemical series this time as opposed to the reactivity. They're slightly different, they're pretty much identical. There's only a few sort of changes, but I'm going to use the electrochemical series. So metals higher than copper in the electrochemical series, and I will explain what the electrochemical series is in a later lesson though, okay, when we start looking at reduction, oxidation reactions, etc., voltage, blah blah blah. So metals higher than copper in the electrochemical series will react with acids. Okay, just a wee sort of side note here, copper, again very much like with the water one, copper does not react with acids. Yeah, and we'll highlight that because that's important. Copper does not react with acids. It also doesn't react with water. However, it does react with oxygen. You can get copper oxide. But anyway, I do have an electrochemical series here. Don't worry about this, the right column just now. Let's focus on the metal. So here's copper. So basically what this means is that every metal above copper will react with an acid. Okay, so lead, tin, nickel, iron, all the way up to lithium. All these metals will react with an acid. However, silver, mercury, gold, copper included, obviously, they don't. Yeah, they don't react with acids. They also don't react with water as well. Okay, and that's how it works. That's how it works. Right. Again, you already know this, but we'll just add it in. The gas released burns with a pop. Okay, now this, the other product we're going to get, hopefully you had a go at it, it is a salt. Okay, so salt's one of the products we get in a neutralization reaction, and it's also a product we get when we react a metal and an acid. So again, that's our three reactions, yeah? Metal plus oxygen gives a metal oxide. Metal plus water gives a metal hydroxide plus hydrogen. And a metal plus acid gives you a salt plus hydrogen as well. Okay, you need to know them. You need to know them. Right, now this method here. Okay, so a metal plus an acid is used to produce soluble salts. Okay, and remember the word soluble just means it can dissolve in water. Okay, so this method is used to produce soluble salts. So what happens is excess metal is added to the acid, and all we mean by that word excess is more than required. Okay, so we add loads of metal, way more than is ever going to react with the acid. That's what we mean by excess. So excess metal is added to the acid, then once the reaction has stopped, the mixture is filtered off. Okay, and filtered, that's filtration. Yeah, that's one of our methods to separate mixtures. So it's filtered off, and that remove leftover metal. Yeah, any metal, because we've used excess metal, we filter it off to remove any leftover metal, any metal that hasn't reacted. Then the filtrate, okay, that's the solution left over. Okay, the filtrate is evaporated to dryness. Okay, so all we're left with salt. Yes, salt crystals would be left with. Okay, and that's it. That's all you need to know about the three reactions of metals. Okay. Yeah. So what we're going to do now is we are going to start the next section of this, and it's called extraction of metals. Now I'm not going to finish it, I'm simply just going to introduce it. Okay, I'm just going to introduce it. So extraction of metals. Now extraction just means to sort of extract, to remove the metal from its ore, essentially. So when metals are extracted from their ore, and again this is all stuff you would have done in third year, so hopefully it's all coming back to you. So when metals are extracted from the ore, and what we mean by an ore are rocks containing metal compounds. Okay, an example of that would be iron oxide. Okay, so that's what an ore is. It's a rock containing metal compounds, iron oxide. So what we want to do is we want to extract that iron. In the case of iron oxide, we want to extract that iron from iron oxide. Yeah, that's what we want to do. Okay, so when the metals are extracted from their ore, they undergo reduction reactions. Okay, they undergo reduction reactions. Now, I'm not going to go into detail about what a reduction reaction is. You might already remember it from third year. I will hit on reduction reactions in a later lesson, but for now, what you need to know is that when we extract a metal from its ore, it undergoes a reduction reaction. Okay, so what that means is that the metal ions gain electrons to form metal atoms. Okay, that's the whole point of reduction. It's all about gaining electrons, but like I said, I'll go into a lot more detail about that in a future lesson. So just to sort of recap this, sort of summarise this, so a metal ion, it could be something like iron Fe2+, yeah, that's an ion, it's a charged particle, and that gains 2 electrons, yeah, Fe2+ gains 2 electrons to give iron atoms, yeah, and that's what we're after. We're after that iron, we're extracting that iron out, okay? Right, the method used to extract a metal from its ore depends on the position of the metal in the reactivity series. Okay, however, the reactivity series is slightly different than the sort of electrochemical series, but we'll use the electrochemical series to guide us. Okay, depends on the position of the metal in the reactivity series, but what we can do is we'll use page 10 in the data book to help us. Okay, and again, that's page 10 there, you've seen that. Okay, I'll talk about this next lesson. Okay, so next lesson we will look at 3 methods of extraction. 3 methods of extraction. Okay, we want to extract the metal out of its ore. Okay, now the first one is the simplest one, yeah, it's just heat alone. Okay, and we would use heat to extract silver, gold and mercury. Okay, they're not very reactive metals, so heat alone is usually enough to extract them. Okay, now if heating a metal doesn't work, okay, we need to increase the intensity. So if heating doesn't work, we need to heat with carbon or carbon monoxide. Okay, so if we've got a metal and heat doesn't work, we need to heat with carbon or carbon monoxide. Now, if that doesn't work, okay, like, oh my god, that doesn't work, we need to up it even more, okay? And what we would do is a term that you are familiar with. We would need to use electrolysis. Okay, now if you can remember what electrolysis is from Unit 1, that is where we are separating an ionic compound using electricity. Okay, so lysis means to separate, electricity, so electrolysis means to separate an ionic compound using electricity, and that works for aluminium and above. Okay, so heating alone works for silver, gold and mercury. Electrolysis works for aluminium and above, and then everything in between works heating with carbon or carbon monoxide. So what I mean by that, yeah, silver, mercury and gold, yeah, all you need to do to separate their ores out is just to heat up. Yeah, just heat it. Now, when we get to copper, we need to start using heating carbon. So with copper, lead, tin, nickel, iron and zinc, we need to heat with carbon or carbon monoxide. Now, anything aluminium and above, so aluminium, magnesium, sodium, calcium, potassium and lithium, we need to use electrolysis. So it's split into 3 sections here. Okay, so that section, heat alone, zinc down to copper, heat with carbon or carbon monoxide, and aluminium and above, electrolysis. Okay, and you need to know that. You need to know that. So let's sort of recap this lesson. That's us for today, but we need to recap it. So metallic bonding, I'm not going to really go over that because you should already know that from Unit 1. That was literally a recap of Unit 1, so I'll let you do that at your own time. What we learned today is that there's 3 reactions involving metals. Okay, you've got metal plus oxygen, metal plus water, metal plus acid. Yeah, metal plus oxygen gives us a metal oxide. Okay, a metal plus water gives us a metal hydroxide plus hydrogen. Yeah, so let's say we used calcium. Calcium plus water would give us calcium hydroxide plus hydrogen. Yeah, and just remember that copper does not react with water. Okay, so anything above copper reacts with water, anything copper and below doesn't. Yeah, nice and straightforward. And the last reaction that we went over was a metal plus an acid gives us a salt plus hydrogen. Now you know how to name salts. Yeah, let's just say for example, in fact maybe if I write this down, I'll write this down a different colour. Let's just say we went for lithium and sulfuric acid. Yeah, to name the salt, we just take the lithium. Remember, if it was a base, we take the first part of the base, which is the metal. Okay, so this would be lithium, and we change the acid. Because it's sulfuric acid, this becomes lithium sulfate plus hydrogen. And that's how we do it. If this was magnesium and hydrochloric acid, it would become magnesium chloride plus hydrogen. Okay, now we use a metal plus an acid to produce soluble salts. Okay, and we always add excess metal to the acid, and then once that reaction is finished, we can filter off the metal, and the solution that's there, we can evaporate it off to dryness, and we're going to get our salt crystals. Yeah, and then finally, extraction of metals from their metal ores. Remember, an ore is a rock containing a metal compound. Yeah, iron oxide, for example. They undergo reduction reactions. Make sure you know that. When we're extracting metals, it's a reduction reaction. It's all about ions gaining electrons to form atoms. Yeah, and then finally, There's 3 reactions we can use depending on what metal it is. Heat alone works for silver, gold and mercury. Heating with carbon or carbon monoxide works for anything above them but below aluminium, and then electrolysis works for aluminium and above. Okay, so that's us. Thank you.